Is it working? Testing 1, 2, 3. It is working. So on page 298, you have this. It says, you can look in your book or you can look up here. It says, most of the paragraph proofs, flowchart proofs you've done so far have been set up for you to complete. Creating your own proof requires good reasoning, strategy, and planning. One excellent reasoning strategy is thinking backward. Oh, how would I figure out? So what it says is this guy is holding the end of this hose, and he doesn't want to turn on the wrong hose, because if he turns on the wrong hose, these things are going to go flying all over the place, and hurt somebody. So how can I figure out? Who can look at that picture and figure out which hose the other firefighter should turn on? What do you say there, Ryan?
I don't know.
Why? How did you do that?
I just went where she's holding it.
Yeah, sometimes the best strategy is to work backwards, right? You don't want to turn on this, you don't want to follow this one, then follow this one, then follow that one, right? To figure out which one he's holding. It's better if I go backwards, right? To figure out the answer, and then work backwards. So if I trace this one, goes like that, loops around, eventually goes back to problem 2. So that is one strategy for solving a problem. So the next problem is kind of fun, and it's in your book, I think on page 300. Let me see. Next, we'll get into proofs in a second. But where'd it go? Okay. Page 300, nothing there. Where's page 300? No. Wait. Oh, there was one. There. Okay. So this thing is don't cheat and look at the answer, okay? Because it's step 1. Using this by the way. All right. So what you have to do in this case. So here's the puzzle. Let's see if you guys can figure it out. You can look up here or look in your book. But it says here's a puzzle for you to solve. Nothing to do with square roots, even though it's called the square root. There's a pun on the word root, R-E-O-U-T-E. So what you can do to move from square to square, you can either, you have to do something with 2 or 5. So to get from here to here, you either multiply by 5, or you add 2, subtract 2, divide by. These are the rules you can use. So you can move to an adjacent square this way, or this way, by either you can add, subtract, multiply, or divide the number in the square you occupy by 2 or 5. So can I move from here to here? Yeah. Can I move to 1? Yes. Can I move from here to here?
Yes.
Can I move from here to here? Yes, right? By adding 2, by multiplying by 5, by multiplying by 2, right? So you want to figure out how to get from square 1 to square 100, right? But again, in this one of the best strategies is to work backwards, okay? So let's see if you guys can look at that and figure out how to get from square 1 to square 100 using those rules, okay? Take a few minutes and either, yes? Got it? Okay, so that's kind of fun, right? So what that shows you is that sometimes the best strategy is to work backwards, okay? And that's the case for doing proofs sometimes. So we're going to look at this little proof that they have in the book. We're going to do it together, okay? As a practice. Where did it go? This one right here. So with this one, what we're trying to prove, okay, is given dart, this is called a dart. A dart is like a kite, except it's got a dent in it, okay? So in a dart, what's special about a dart is 2 of the adjacent sides are congruent. Just like that, 2 pairs of adjacent sides are congruent. Just like in a kite, except it's concave versus convex, okay? And it asks you to show that CD CD bisects angle ACD. So think backwards. What would I have to show, what would I have to say to prove that CD bisects ACD? What angles would have to be congruent?
ACD and BCD.
Very good. This one here, ACD and BCD. I'm going to just call it angle 1 and angle 2, right? If I can show that angle 1 is congruent to angle 2, can I say that CD bisects that? How could I show that angle 1 is congruent to angle 2? Proving what are congruent, Ryan?
Two triangles.
Very good. Proving that two triangles are congruent, right? Working backwards from there, do I have enough information to prove that these two triangles are congruent? What is it, Drake? How would they show?
Side, side, side.
Right? This middle side is congruent, right? So that's kind of, see how I work backwards to think about how I would prove something? Because sometimes people say, oh, I'm just going to start writing stuff down. It's better to figure out, what do I have to say to show that this is a bisector? Well, if angle 1 and 2 are congruent, it's a bisector. If the triangles are congruent, then angle 1 and angle 2 would have to be congruent by CPCTC. Are the triangles congruent? Yes, by side, 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 side. So if I were going to write this up as a little proof, okay, where's my, not that thing, not that, this thing, no, cancel. Where's my freehand shape? Not freehand shape, I want shape. Where's shape? These. I want a rectangle. I don't want a shape angle. Nothing. So if I wanted to do this as a little flow chart, 1, 2, 3, okay? I could first put my given into there, right? I could say that AC is congruent to BC. I could say that AB is congruent to BD. What's the reason for those two things? You should be copying down some notes or something. Okay, well, this one's in your book, but what's the reason for both of these? Why is AC congruent to BC? Given, right? Given. What's the third piece I used? CD is congruent to itself, right? CD is congruent to CD. Okay? And that's, you could say, same segment. Then we put those three things together, right? To point to, put those three things together to point to the fact that triangle ACD is congruent to triangle BCD, triangle BCD. Let's fix that. Triangle BCD. Why? Side, right? Okay. Then I went from there to say that what's my next step? Go ahead, Ben. What?
Angle 1.
Angle 1 is congruent to angle 2. Angle 1 congruent to angle 2. Why, Ian? Why is angle 1 congruent to angle 2? CP, yep. CPCTC. And finally, if those two angles are congruent, then I can say, therefore, right? Therefore, by definition, okay, CD bisects angle ACB, depth of an angle bisect. Depth of an angle bisect. Okay? Get it? Yes? No? We're going to do another one. Can we do another one? We're going to do number 4 on your homework. Okay? So, moving on. We're gonna go to number 4 on your homework. Where is it? Hey, just like we did, 4. Or at least I'm gonna try to help you get it set up, okay? So this is an interesting one. Develop a flowchart proof for this. Let's see if I can make it bigger. Make it bigger? Okay, so you might say, so developing a proof, write a flowchart proof to demonstrate that SOAP, S-O-A-P, is a parallelogram. This is part of your homework, so you might want to just copy it down and make it. I'll at least get you started on it, okay? Quadrilateral SOAP with SP is parallel to OA and SP is congruent to OA. So what they're telling you is that this side is congruent to this side and it's also parallel. That's all they tell you, and they want you to prove that this is a parallelogram. So what makes something a parallelogram? What am I missing that it doesn't have in there that would make it a parallelogram? Go ahead, Ryan.
If SO was parallel to.
Right, so basically you have to very good. You have to say that you have to prove that SO, right, is parallel to AP. Then since I already have one parallel sides, right, a quadrilateral with 2 pairs of parallel sides is a parallelogram. So I have to try to figure out a way to prove that those 2 things are parallel. Working backwards, what would allow me to say that AP is parallel to SO? Which angles would have to be congruent? Ashley? Which angles would have? I heard someone.
Like 1, 2, 3, 4, or like the.
Yeah, like 1, 2, 3, and 4 out of those
Okay.
ones.
3 and 4.
Very good. If I can show that 3 is congruent to angle 4, right? If I can show that angle 3 is congruent to angle 4, if those alternate interior angles are congruent, then what has to be true about these sides? They're parallel, right? Do I have a way to show that these alternate interior angles are congruent?
Yes.
What would I have to do to prove that those alternate interior angles are congruent? Go ahead, Ben.
But the 2 triangles are congruent.
That the 2 triangles are congruent. Do I have enough information to show that the 2 triangles are congruent? How?
You have single side side? No. Side.
You have a side, right? Then you have which angles are congruent? You're right.
3 and
Not 3 and 4. That's what you're trying to prove.
Yeah.
That angle 1 and angle 2 are congruent. Why? Because what kind of angles are 1 and 2? Those are alternate interior angles formed by those parallel lines. So I have a side, angle 1 and angle 2, and the middle side. See that? So it's a kind of complicated proof. So you kind of have to think backwards. Okay? So kind of, you want me to go through that and show you what it would look like if we did? So the first thing that I'm going to say, I'm going to list my givens. Okay? I'm going to say that, let's do it as I'm going to do it just to be different. I'm going to do it as a 2-column proof. Okay? Because, well, those shouldn't have arrows on them. 2-column proofs. Have we done any 2-column proofs? A little bit, not really. Okay? So 2-column proof, basically over here you have a statement, and then you have a reason. You can do this as a flowchart proof too, but I just want to expose you to a 2-column proof. This is the way I learned it when I was in high school. I do proofs. So kind of what you do is you list your stuff in order as you should. Okay, so first you would say that SP is congruent to OA. Why is SP congruent to OA? It's given. Okay? And then I also said in step 2, who thinks this is easier? Who likes this better? Right? Some people like it better. With the flowchart, I like it because you can kind of see how it all fits together. Okay? Because sometimes with these paragraph proofs, that was my problem in high school. I can never see how it all fit together. With the flowchart proofs, you can kind of see how it fits. SP is what? Parallel to OA. Okay? And that is That's given as well. But then from that, who can tell me what my next step would be? What other than Ryan? Can anyone tell me what my next step would be? Go ahead, Drake.
Is it the diagonal that it's the same?
Yeah, let's hold off on that one. This being parallel to that lets me say that which two angles are congruent. Okay, so angle 1, right? This being parallel makes angle 1 congruent to angle, what? 2. And those are alternate interior angles, okay? Alternate interior angle theorem or conjecture, interior angles, okay? Conjecture, really. Then I'm going to say what Drake said, which was that was that PO? What did that say?
Yeah.
PO is congruent to PO, right? Or you should really call it OP, but we'll just leave it there. And that's the same segments. Who can tell me what my next step would be? Next step. So far I have I have a side here, right? I have an angle, and then I have another side, right? So what am I going to say my next step? Go ahead. Yeah, then now I can say that my triangles are congruent, right? So I'm going to call this one triangle, let's say that triangle S, let's call it SPO. SPO is congruent to triangle, did I call this SPO? I'm going to call this AOP. AOP. Why? Why is SPO congruent to AOP? Did I put that in the right order? SPO, AOP. What? Side angle side, right? What's my next step? Next step. Remember, I'm trying to prove that those lines are parallel. Go ahead, Sana. Very good. Angle 3 is congruent to angle 4. Why? CPC. Corresponding parts are congruent, triangles are congruent. Which allows me to say that, not yet. First you have to, so why did I want to say that 3 is congruent to angle 4? To show that which sides, to show what? To show that these two sides are parallel. So now I know that side AP is parallel to side SO, right? And that's really called the converse of alternate interior angles, which says that if the alternate interior angles are congruent, then the lines are parallel. That's the converse. And the forward saying is if the lines are parallel, then the alternate interior angles are congruent. And then finally in state 8, now I can say what that I'm trying to prove. SOAP is a parallelogram, okay? And that's really the definition of a parallelogram, or it'd be better to write a quadrilateral with two sets of parallel sides is a parallelogram. You could say definition of a parallelogram there, but I just really want to spell it out. So the problem with this is kind of hard to see what follows from what. That's what I always had trouble with when I was in high school, because I didn't understand why are they writing this here and not here, and I got all confused. With the flowchart, I think it's kind of easier to see how everything kind of fits together. Like I put my three pieces together to prove the triangles are congruent. From that, I draw an arrow to here. Whoops. I draw an arrow to here, and then from that, I draw an arrow to here, and then I take this piece and this piece, and draw arrows from here and here to show that SOAP is a parallelogram. But this works as well. All right, got it, sort of, maybe? Okay, so I'm gonna stop, see if